Okay, so today I'm going to talk to you about the powerful toolset of the Go-Mysql library. Who of you here is using Go in like his day project? 2 hands. So Go-Mysql library, that's a library that I'm going to talk about today. So I'm Daniel Van Eden and I'm working for PingCap on TidyB. TidyB is a very scalable, distributed, MySQL compatible database. It's not MySQL, it's a re-implementation written in Go, Rust and a few other programming languages. I'm not going to talk about TidyB itself. If you're interested, look it up online. TidyB is a really interesting database. I'm also a long-time MySQL user. Before I worked at PingCap, I've been working at Booking.com and a few other places where we used MySQL extensively. So I really know the whole MySQL ecosystem quite well. I'm also a contributor to like a lot of MySQL-related projects. I'm contributing to Wireshark for the MySQL protocol decoding. So you capture network traffic, and then like this tool can extract all the information out of the network traffic to like show you what's going on, which is a really useful debugging tool if you're having network connectivity issues with MySQL or maybe want to do something different with the MySQL protocol. I'm also working on TidyB, of course. I also try to do some contributions to MySQL every so often. And I'm also working on the DBD MySQL driver for Perl. So if you're writing anything in Perl and you want to connect to the database, that's also one of the things that I work on. Today I will demonstrate various use cases of Go-MySQL for you. Go-MySQL was created by Sid and Tang in PingCap. He's the VP of engineering now. It's quite active on GitHub with a lot of contributors, a lot of stars, and it's an open source license that we're using. This library is being used by a lot of different tools that you may or may not know, like Spirit, Ghost, YDB, and also TidyB DM. That's one of the products that we have for migrating from like a MySQL database to a TidyB database. So that's one of the places where we are using this library. The examples that I will be giving you today are made to fit on the slide, which means that error checking is left as an exercise to the reader. So if you're doing this in your own code, you need to add some more error checking, but that just doesn't fit on the slide. The right import statements are also usually left out because it doesn't fit on the slide. The larger examples will not have code on the slide, but will have code online for you to look at later. So the Go-MySQL project is native Go code. There's no C code involved, which means you can really easily compile and cross-compile the code and import it in pretty much any Go project without any issues. The very first thing that this allows you to do is work with replication. MySQL has the whole replication stream, which means that the MySQL server writes binlog data to disk, sends it over the network to any of the replicas, but also you can make your own library that reads this data and reads from this replication stream. So this library can request a binlog stream from a server, just like a normal MySQL replica can, and then process all the events. It's recommended to use the row-based binary log format because that makes it much easier to work with these events. So this is the first slide with some of the code. If you're not using Go, this might look a bit foreign to you, but the basis is quite simple. So you first have a configuration to tell like where the server is located. Then you set up the new binlog syncer. You start replicating from a specific binary log file and a position. Then you're looping over the events, and here it will just print out the first column and the value of the first column. So if you run this code against the MySQL server, it looks like this. So on startup, it shows you the configuration of the library. It tells you where it's starting to synchronize from. And then you can see that it's indeed printing out the values of the first column when inserting some rows into a MySQL server. By the way, feel free to raise your hand and get my attention if you have any questions or if I missed something. We also have a different API for looking at the binary log events called Canal. So here you're working with the same set of events from a MySQL server, but the code looks slightly different. Here we are also connecting to a server. This time we're using GTID, because that's also something we support instead of a file and position. And then we are defining a handler, and this handler is being called, has a function that's being called for every row. This is the onRow event, and then it will print out a line with the events. So this will basically do the same as the code that we saw before, but it's just a different API basically. So here you can see the similar output. You see that it's printing out from where it's starting, what the version of the server is that it was connected to. And then you can see that it's indeed printing out the value of the first column when we're inserting some data into MySQL.
Is there specific use cases to use Canal over replication, or is it just a different implementation?
Okay, so the question is are there any specific use cases when to use when to use the other? It's just up to you if you want to use Canal or the other interface. I think it's a bit of a choice between a slightly lower layer and slightly higher layer one, and a different way of more event-based processing. And it depends on what you want to do with these events, on which of the APIs you want to use. But most things can be accomplished with both of the APIs. And then another use case that someone asked me about recently at a MySQL meetup was well, they said we have a set of binary log files and we want to record what the GTID range is in every file, because we want to know if we have an issue with a transaction, in which file we have to look to see what the transaction was looking like. So I just wrote some example code for this. So basically what this code is doing, it is just reading in a set of binlog files. And then for every binlog file, it's just looping through all the events in the binlog file, recording the GTID, and then storing the GTIDs together to not just get a whole list of the GTIDs, but get a summary range for every GTID in that file. So this is the main function of the example program. Here we are reading the files, looping over the files, and printing out everything. The only thing that's not included here, that's on the next slide, is the process event, which is the function that we're calling on every event. And that's on this slide. So here we're just looping over the event, getting the GTID events, and then combining all the GTIDs into a single GTID set that we can summarize and display. So this is what this tool outputs. If you like feed it a list of files, for every file it will list like, well, this has this UUID with transactions 1 to 2. And the next file has like transactions 3 to like 141, etc. There might be a few files that don't have any transactions in them because of reasons. And the very last line is just visible on the slide. It actually has like 2 different UUIDs in there, because there might have been like a switch over, for example. So this is just one of the examples of the things that you can do by just reading the binary log stream or the binary log files from MySQL, using the library and doing whatever you need to do with it. One of the other things that this library can do is it can like act as a MySQL server, but you can just tell it to do something like how to respond on like certain queries. So on the slide is an example from a MySQL server basically that's listening in port 4000, and if you connect and you send the query select 2.2+2, it will return a result, and otherwise it will just not return anything. So this is a really simple one, and how it looks like is this. You start the server, you connect, you do a 2+2 and you get 5. Of course this is not what a normal MySQL server would do, but you can make it do anything. This is useful for testing, useful if you want to create a honeypot, useful for like experimentation, these kinds of things. Another example here, this one doesn't fit on the slide, so the code for this example is available online. A new server, we can do a create table, insert into, doesn't look very special yet. We can select from the table, looks like a normal MySQL server. But then we continue and it stops to look like a normal MySQL server. So you can get a SQLite version and a table list, but with a different syntax. So basically what was happening here is that we create a MySQL server that accepts queries, runs it on SQLite, and returns the result. So it makes SQLite look like a MySQL server. I'm not saying you should be doing this in production. I don't think that would be a smart idea to do, but this is an interesting way of testing things. And this also means that you can do the same with Postgres. So basically, by using this server, and then connecting to Postgres and sending the queries there, and translating the results again, you get Postgres that's working with the MySQL network protocol. So that's a fun thing to do. So what's included for the server part? It's only the MySQL protocol for the server part. There's no MySQL syntax included. Both TidyB and Vitess have parsers. So if you want to do anything with parsing queries, there are different projects for that. It also doesn't include the optimizer, it doesn't include a storage engine, but it allows you to do like many interesting things. So security testing is one of the things you can do, education, experimentation, and also you could make services available that are normally not available over the MySQL protocol, which can be useful. Besides all of this, we also have a database SQL driver. It's a pure Go driver for the Go database framework. It's very similar to the more well-known Go-Mysql driver. Yes, it has like a very similar name also, so it can be a bit confusing. So basically what this looks like is you just open a connection, you run a query, you print out the result of the query. It does what you think it will do. But we also have a low-level client, which the other driver doesn't have. So here you're also connecting and executing a version, getting the result, and printing out the version. So it looks the same, but it's a different kind of driver. But this also means that we can do all kinds of other interesting things. So here we are printing out the server version without sending a second query. The result is the same, but if you look on the network, you can actually see that like the first demo is sending more queries to the server, and the second one is sending less queries to the server because it's only like 4 network packets. And this is because if you can connect to a MySQL server, it's already sending you the version. So there's no need to actually ask for it. So that's what we're using here. Besides this, there are also like a few other things that are possible with this low-level driver that are not normally possible with the database SQL framework in Go, like sending attributes and a few other like MySQL specific things. I created another like example of what you could do with this project. So basically we're going to try and emulate materialized views, or like so we created a test database. We created a table T and a table MV for materialized view, and then we start the server. This server is also based on code that's available on GitHub later on. So there are basically 2 tables, and there's nothing special about these 2 tables. And we're inserting in the T table, and we're inserting the values 1 and 2. But then we are selecting the value average from the MV table. This wasn't any special table, but it does give us a result. That's actually the average of like 1 and 2, like 1.5. So we can also just use the normal average function in MySQL to get the same result. But the difference here is that if you want to do the average value, it's reading 2 rows. For this materialized view is only reading 1 row, and this is with a very tiny table. So if you have a giant table, this might be a way bigger difference. So what is this materialized view code doing in the background? It will connect to the server, and it will start to listen for binary log events. Well, first it will run a query to get the count and the sum of table T, and record a GTID position, then to start a binary log stream. Then it filters out events for table T. So if we're inserting anything in table T or deleting, updating, it will use this event, and it will adjust the count and total that it has for this value. So it does this for every transaction. Transaction can be a single row, it can be 20 rows, it can be 1,000 rows, but then it will update these counters, calculate a new average, and write back the average to the MV table. This means that this is not in the same transaction, so this is not like completely real time, But for many cases, this might be good enough to get a quicker result than that a normal query might give you by just keeping like a pre-calculated value in this table. So that was all I had for today. Any questions?